Hi, in this video we're going to tabulate an election using proportional approval voting. And the specific form of proportional approval voting we're going to use is called sequential proportional approval voting because it elects the candidates sequentially one at a time until we've elected the desired number of winners. The process is we just add up all the votes in each group to determine the winner for that round. Then from right to left we just transfer all the ballots that approve the winner, moving them one group to the right. And then we just repeat that process until we've elected the desired number of winners. So here in round one, all of our ballots are just in one big group. There's 2,500 ballots. Our candidates are W, X, Y, and Z, and we're going to elect 3 of them as our winners of those 4. So when we tabulate them here, we get these results, and clearly X is the winner with 1,200 votes compared to these other totals for the other candidates. So now we're just going to move all of those ballots that approved X and move them just one group to the right so that in round 2 we have these new tallies here. So group 2 has 1,200 ballots. Those are the 1,200 who approved of X. We tallied them, and now W has 43 votes, Y has 311 votes, Z has 288 votes. Then in group 1, W has 446 votes, Y 819, and Z 532. And then below the tallies, we just have sort of the weighted result. So we take, for instance, the group number here is 2. So we take these tallies and we just divide them by 2 to get the effective votes. So W here is 43 votes, divide that by 2, that's 21.5. Y is 311 votes, divide that by 2, it's 155.5. And then Z with 288 votes, divide that by 2, it's 144. In group 1, of course, dividing by 1 doesn't really change the result, so these numbers look the same. So 446 votes for W, down here is 446, but the basic idea is that for every group, you take the tally, you divide it by the group number, and that gives you your effective tally. And that is what makes it proportional, that division, that the more candidates you elect, the more power you spend so that your vote has less influence in subsequent rounds. That is what drives the underlying proportionality. So here we see that W has a total of 446 votes from group 1, 21.5 from group 2, and that adds up to 467.5. Y has 819 plus 155.5, and that's equal to 974.5. Z has 532 plus 144, and that's 676 votes. So Y clearly is our winner. So first we elected X, and now Y is our second winner. Now after this, we're going to move all the ballots that approved the winner one group to the right, and we go right to left to do that, right? So we start here and we say in group 2, we're going to take the 311 ballots that approved of Y, and we're going to move them over to create group 3. And then in group 1, we're going to take the 819 voters who approved Y, and their ballots are going to move to group 2. So group 2 first loses some ballots, then it gains some ballots. So here in round 3, those 311 voters who approved of Y move from group 2 to group 3. So here we go. And all these voters in group 3 are people who they initially approved of X, X1, they moved over to group 2. Then when Y won, they moved into group 3. So they have all voted for at least two of the winners thus far. Right? So of the 2 winners, everybody in this group has approved both of them. And so their ballots here, when they tally, are going to be 31 votes for W and 102 for Z, but then the effective total is just dividing this by 3, because we're in group 3. So 31 divided by 3 is 10.3. Z has 102 votes, divide that by 3, it's 34. And then again, divide the second total here by 2. So 231 votes for W is 115.5. 319 votes for Z is 159.5, and so on. We do the same thing for group 1. Of course, as we said, dividing by 1 doesn't do anything, so these numbers look the same. But again, we just go ahead and tally these bottom totals here. So W has 227 plus 115.5 plus 10.3, and that equals 352.8. Z has 399 plus 159.5 plus 34, and that's 592.5. And so Z is our third winner. Sorry, W. So basically the idea here is that there is a little bit more manual work to do. You have to tally the ballots one time for each round that you pick. So if you're going to elect 3 people, you tally them 3 times. but there's no fundamentally like additional complexity. You're just using the same voting machines you've already used. Doing this division step here is very straightforward and can easily be done with just a pencil and paper or a calculator if you like. Any observer can easily verify the math was done right. It's just simple division, nothing complicated at all. And yeah, so it's very quick and cheap. You could imagine that if a community adopts this method, eventually they would probably want to get some voting machines that just do this all automatically, which you could do if you want to do that. You get those certified, and then you just have something that does the whole process for you all at once. But even in the early manual stages, it's very straightforward. It doesn't require any kind of additional voting machines or any kind of certification processes. So there's no bottlenecks or cost to hold it back. Any additional modifications or upgrades you do to your voting machines would just be for added convenience. You don't have to do them. So that's how it works. It's very simple. You can use the voting machines you already have, and you have sequential proportional approval voting.